Hey, so this is the second video in a mini-series that involves semantic kernel, and in this video we will look at inline prompt functions. So this is the accompanying blog that will cover the code walkthrough. Specifically what we'll look at are 5 different ways that you can implement prompt functions in semantic kernel using Visual Studio and the OpenAI GPT-4 model. So the 5 main examples that we'll look at will cover inline prompt functions, how to ensure predictability when working with prompts, how we can refine the LLM prompt output, how to implement few-shot prompting, and how to handle expected user input. And each of these examples will be covered as part of a discrete console application. So what we'll do now is we will jump out of the blog, and what we'll then look at is Visual Studio. So here we're in Visual Studio, and this is the first example. Very simple example, and what this does is between lines 30 and lines 33 is the agent asks what the user would like to do, and then we take that, put it into a variable called request, and then send that prompt over to OpenAI, specifically the chat completions service, and then we print the results. So what we can do now is we can run this application, and when it spins up the console application, we'll get the prompt, and it's concatenated onto a string that says what is the intent of this request. So we could say something like, I would like to book a flight. And if we step over this line, we'll see that the OpenAI model has been able to identify the intent of that particular prompt and user input. In the past, I probably would have to have created a language model using a service such as LUIS, the Language Understanding Intelligence Service, or CLU, which is now taking place of LUIS. What we've seen here is we can send over a prompt request via semantic kernel to the OpenAI endpoint and then get a response back from that in just a few lines of code. So that's the first example. Next we'll move on to example number 2, and that's how we can ensure the predictability of generative AI. So we'll stop the console application, and generative AI is pretty powerful, but it's also unpredictable. And sometimes what we need is a way to ensure that the language model will only handle a discrete set of actions. So that's what we can see here between lines 44 and 56. We can hone in on the initial prompt on line 44. So we, again, like before, we say, what is your request? We let the user know that there are 3 options available. But if we look down at lines 48 and 49, what's a little bit different here is we instruct the model that the available options are get next booking date, make a booking, or file a complaint. And again, like before, we construct that prompt, then we send it over to the model. So what we'll do is we will comment out the code for the first example, and we'll run the second example, and we'll see how this will behave. So just like before, we get a prompt in the console application, and we get a little bit of a nudge that says, or suggests rather, what the 3 options are. Okay. If you look back over to the code, we can see that on line 49, we're explicitly telling the OpenAI model, mainly GPT-4 in this case, via semantic kernel, that we will only expect one of these 3 options. So you can say something like, I want to perform a booking, please. And if we open the console application, we'll see here that the model has given us more structured data to work with. So we passed in the text, I want to perform a booking, please. And by sending that over to the prompt with that enumeration of options, the intent has been identified as make booking. So that gives you more control over being able to code business logic or rules around a particular intent. Again, like before, using something like LUIS or CLU, you probably would have to have created a specific set of utterances and then created an intent called bookings. So one intent could have many utterances, and that would train the language model. But what we can see here is the key difference is that the OpenAI model is able to identify the intent via semantic kernel by prefixing the prompt and letting the model know what the available options are. So next up is example 3. So we'll stop the console application and we'll just comment out example 2. And then here we can see we've got example 3. So before we were able to direct the LLM and give it some set of or some idea as to the options that are made available. That is useful, but there's another way, okay? And that's what we can see here between lines 60 and 63. So what this lets us do is to further refine the output by adding some structure to the prompt. And we do that by adding the options that are available in the choices prefix. And we can see that at line 61. So what we'll do is we will run the solution again. And we get the prompt. And we can see here that we're able to infer the intent again. Now, it's similar to before, but prefixing the prompt with the choices attribute will make it much more easier for the language model to determine the intent that was being expressed. What you might choose to do is to take that intent and then invoke a particular API or some custom business logic. So we'll stop the application again and we'll move on to example 4. Now, example 4 covers a concept called few-shot learning, and basically the examples that we used before were implemented using what is known as zero-shot prompting. This is fine generally in simple scenarios where questions and responses are straightforward, but you might need more nuance due to similarities in sentence style or prompts a user may supply, but that must be treated differently. So, for example, you may have a prompt that says something like, "Can you tell me how to make a booking for the next available date?" Well, it's possible that the LLM may select either get next booking data or make booking for the above example. What we can do is we can give the AI model a slight steer and some help by providing some examples of a phrase for each of these. And that's what we can see here between lines 77 and 81. And these help disambiguate the nuance between the human language that may be supplied. Like before, what we do is we can use this to construct a prompt, which is then sent over to the OpenAI model via semantic kernel. So we can run this again. Put our console application and I shall paste in some text. So here we've got, "Can you tell me how to make a booking for the next available date?" And semantic kernel invokes the OpenAI endpoint. And if we look at the console application, we can see that the model has been able to disambiguate that particular request and identify the correct intent. And as I said before, it may have struggled without examples that were set via the few-shot learning developer approach because we have get next booking date and make booking set up as intents. But by implementing few-shot learning, it just gives it a helping hand. And finally, we move on to example 5. Before we do that, we shall comment out example 4. And example 5 is around handling random user input. Okay, so there's times when an LLM may not behave as you expect. That might be due to insufficient training data, examples, or system prompts. And what we can do is we can handle these situations by telling the LLM how to behave and what corrective action to take. The way that we do that is by adding some additional instructions, and that's what we can see here in between lines 96 and 97. So what we'll do for this particular scenario is we'll ask the LLM what time it is. Now, it cannot connect to real-time services with its current implementation. We'll talk about that in another blog series and video, but because we have set in line 96 through to 98, how that should be handled, the LLM will respond with a suitable response. So we can see here, what time is it? Semantic kernel does its thing, and we've got a response here which says the unknown intent or expression has been sent back as a response. So we can see here that if you don't know the intent, do not guess, instead respond with unknown. Now, in the real world or a real application, you would normally add more of a description, or you may perform some kind of human handoff or send some other particular notification. So that brings the demo walkthrough to an end. In this demo, we have seen 5 examples of using inline prompt functions with semantic kernel when interacting with an OpenAI LLM.